That was in essence the before picture. This is after. These feet have already been milled. All right. I did some layout on them to mark my holes. Let's take a minute and actually make a few chips. Well, I'm grabbing this cutter. Let's talk about this wrench for a second. You don't want to forget the wrench and leave it up there on top. When you do, you turn the spindle on, that thing spins around, hits the motor. Everybody knows what you did. The wrench stops in a hurry. If you're lucky, you're turning in the wrong direction and it unscrews the drawbar. If you're not lucky, it just comes around here and hits seriously hard. And actually that machine was taken out of service because eventually it was hit hard enough that it damaged the motor. The outside of the motor squeezed in on the rotating part, the rotor, and it needed to be replaced. We don't want to do that. Okay, spindle. Making sure that's clean for accuracy. If we got a little bit of dust or dirt on there, or on our tape or on our collet, that cutter won't turn true. If I had a key in there, I would watch that. This little black flexible over here, that's our cooling system. Cooling is optional. Sometimes it'll help the quality of your work, sometimes it won't. You can see where I store my wrenches. You know where they are. We've got one for every machine. We do have magnetic starters. That has an electronic or electrical solenoid that makes our electric contact. If we kill power in here and then we turn it back on, this won't start again. That's our safety button. Here's our main switch. And these machines, almost all these machines, we have a variable speed drive here. Your motor is obvious. Our spindle is obvious. We have a V-belt in there. And we can change the speed of it. We only change it here while it's running. Otherwise we can do damage to it. Our switch, though, has an option of a high and a low range. We can slow this down. We're doing big cuts or things that we want to do with a slow cut. There's a lever on the side. Right next to Ben there. See the lever? This one. If we want to change from high to low, that gets changed with it off. What we've got is a pair of gears in there. And we have to get the teeth in those gears to mesh. We do that when it stops. Hear those teeth? You try and turn it on while it's not in gear, you'll hear those teeth too. So will everybody else in the room because we're grinding those teeth together. Here's our low speed. Lever is horizontal, we're in the high range. Our drawings have specs on how high this piece needs to be when we're done. I believe it is 6 3/8 of an inch. We want to machine the feet to get it dead flat, to get all of our mill surface off of there, our sand cast surface, but that's all. We have a minimum height as far as requirement goes. We can leave it tall. It's not a problem. There's the bolt that I worry about. Knee handle brings it up. Typically with a carbide, either tool, you're not going to touch the work with it while it's not running. We're liable to damage the tool that way, or the part. I'm close, but I'm not running yet. Remember we have a quill in there? Works like a drill press. We have a clamp for that too. In this case, our quill right now is retracted. Release the clamp. I can use it like a drill press. Okay? If we're doing accurate work, and I'm I'm going to say accuracy a zillion times in this class. We don't want this thing reaching out, possibly vibrating. So typically the quill is fully retracted for almost all of our work. So it's up, and there's the quill lock that holds it. Okay. We can change speeds, yes?
I was just going to ask what the speed for that is.
We actually have a lesson coming for speeds. Right now we're cutting aluminum, which is soft, with carbide, which is our best cutter. We can turn it pretty fast, and we're also taking a light cut. Right now we're set for a finish cut, which could be your final pass, and I'm set up around 2300 RPM. For a roughing cut, right now you could probably do it around 1400, 1600, and that would be fine. What we'll do here, as long as we've got our safety glasses on, I'll take a light finishing pass so you can see what she's looking like. Typically what I'll do is start right about here with the cutter, go across this foot, move on my x-axis, come over here and take a cut, and bring it up, go the other way. The shape of a U, and that way I'm not cutting my bolt. Let's start over here. My fly cutter is handy because I can cut the full width of the foot in a single pass. We have end mills that are 1 inch wide, we have end mills that are 1/2 inch wide. If we use those, we're going to take a lot of passes to get it cleaned off. Industry's worried about time and money. They don't want to do a lot of passes. They want to do as fast as they can and hold their quality. Okay, not touching the low of the work. I'm going to bring it up just a little bit so I can see I'm taking a cut. I want to feed at a relatively constant speed to give me a smooth cut.
We're going to do the full U, right, in one depth before we set the next step, right?
I'm coming to the back and then I'll come across to the other foot. What can we do to get a constant speed on our feed, whether it's, in this case, it's on our y-axis? Any ideas on how to get nice even pass? Okay, something you couldn't see while I was doing it, my hand on the handle, I'm squeezing it. My hand is actually working like a brake. So if I turn what I feel is a constant speed and use my hand to actually restrict movement, I can get a smoother single pass. So that's worth trying. We're looking for a quality finish. And a nice even feed rate will help. Okay, on that, we want that minimum height of 6 3/8. Easy way to check it. Take your combination square. Set it at 6 3/8. Set it on your feet. I can now look at what's the top of my part and see if I've got enough metal there that I can take another pass if I wanted to. On this side, something like that. Okay, so I have my feet, I've got a nice even finish. I need to lay out my holes. Our next step, when these are done, after we have the holes, is going to be to mill the sides of this. But the holes are important for that cumulative error. That fixture is stored under the bench where that one is, and it will take our base from here and mount it on the holes so one of those two sides is facing up. And then we'll mill the sides. Those holes have to be right to fit this. Okay? So now we want to lay out the holes. Many people use layout fluid. Good deal. We have some that's over on our layout bench. You can use it if you want to. You can also use a marker if you want to. If you're using the layout fluid, use it over there. Don't like it on my front table. I try and keep the table clean because that's sort of our picture window. And if that looks like crap, it reflects on the whole lab. Okay, we need to drill 4 holes evenly there. Bring out your little marker. Do a little bit of layout work. On this piece, we have to start with a reference from somewhere that we can measure off of. It's like trying to find a straight line on a ball. Just about everything here is curved surfaces. Okay? So, what we're doing is we're going to use our parting line. Right? Line left over from the foundry. It was the drag pattern, coat pattern. Our plate between the two created our parting line on our part. Right? You can see it on the ends. So what I'm going to do there, make myself a mark. Remember our purpose here, locate 4 holes. We can then take the mill, put a Jacobs chuck in it, and drill those holes. Let me grab a chuck.